Hi, my name is Caelen Feller. For my summer of HPC, I've been building interactive, high-performance computing demonstrations for outreach in the Edinburgh Parallel Computing Centre. Today I'll provide an overview of my project, focusing on my results, with an accompanying explanation. For more details, please read my report. Here, you can see the target machine for my project, where I run all of my demonstrations, Archie. Archie is made up of 16 Raspberry Pi chips, each of which have an LED panel attached to it, which can be used to show a simple visual output. Here, the arrows moving between Pis are showing the communication between them, which I'll explain shortly. The main goal of my project was to create visualizations and examples for every type of communication possible with the industry standard library in HPC, MPI, and to make it easy to apply these animations to any existing or future demonstrations by creating a developer-friendly framework around them. I've done this by using Python to run an animation web server on each Pi. This makes it easy to visualize communications, no matter the tools used in the demo, as it all occurs over the network. To demonstrate and test this framework, I've created a series of demos showing all the basic communication types. Here, you can see a send and receive operation, where one Pi sends a message to another directly. When a send or receive is started, the displays will show the source or destination before initiating the transfer between the two, waiting for both to be ready before starting the animation. Here, you can see this concept taken further, with all the Pis passing messages to each other in a loop, which snakes up and down the columns, returning to the start. This could be useful for passing a message around in a circle, or adding up results from all of the Pis. But there is a better way of doing this. Previously, you saw one Pi communicating with another. Here, you can see many of them communicating at once in 4 different ways: broadcasting, gathering, scattering, and reduction. Let's focus on broadcasting. Here, one Pi wants to send a message to every other one, as quickly and efficiently as possible. This is a simplified way of showing this, focusing on the effect rather than the method. Here is a more detailed view of a possible way of doing this. A message passes from one Pi to all the others very quickly, as all of the Pis spread the message once they've received it, creating a tree-like pattern. To make it easier still to develop visualizations using MPI in C and Fortran, I created a wrapper to handle the network requests using the MPI profiling interface, which is normally used to measure performance. This means a developer needs to do no extra work to show their communications with normal MPI code, though they can also use custom animations, as I'm about to show. Normally, there is a computer connected to Archie to allow for interactive demos, which is done here in the most recent demo made for Archie, the Coastal Defense Simulator. Created by my project mentor, Dr. Gordon Gibb, this simulation shows a small coastal town which needs defense from erosion. Your goal is to place concrete barriers in the ocean as efficiently as possible in order to reduce the cost of damages and make a saving working with a budget. Once the barriers are placed, Archie will simulate the waves coming in and the damage they cause to the coastline. To do this, it breaks the ocean into small strips, each of which are given to a single Pi. However, in order to properly allow waves to pass through the simulation from top to bottom, they need to communicate. To do this, after each tick of the simulation, they swap their edges with the Pi above and below them, snaking up and down, as in the loop example previously. This operation is called a halo swap. As you can see in the coastal defense simulation, giving a narrative to a demo is really helpful for engagement. To better integrate all of the demos, I made the secondary goal of my project the creation of a unified web interface for the demonstrations. To test it out, I made tutorials accompanying my basic demos, which you can see now. In these tutorials, you can play any of the demos directly from your browser, if you're connected to Archie. All of this code will be published on the Archie GitHub repository, worked on further by those doing outreach at EPCC, and run at large science fairs and conferences on Archie. I'm really grateful to EPCC and the Summer of HPC program for the opportunity to have worked on such an exciting project with such a meaningful impact.